This video complements the written instructions for adjusting the Case DMI Ecolo-Tiger for top field performance. Sequential steps for setting the Ecolo-Tiger. Pre-field settings. Step number 1. Set clevis height before hooking to tractor by using the chart on the machine. Cross-reference the desired shank depth to tractor drawbar height to select the proper clevis setting. The offset clevis design provides 2 height positions for each hole. Step number 2. Hook to tractor and check to be sure lights operate properly. Step 3. Adjust hose length to keep hoses out of hitch area. Excess hose should be behind the boom post so the boom swings freely. Step number 4. Check tire air pressure. Underinflation will cause tires to squat in tight soil, giving a deeper depth, which requires more power. With correct pressure, the unit holds more consistent depth and more uniform power requirements. If one tire pressure is lower, that side will go deeper and cause the unit to pull crooked. In extremely compacted conditions, some operators on their own increase the tire pressure an additional 10% over the maximum pressure to achieve additional depth stability in the field. This additional pressure makes the tire more subject to punctures, which could be dangerous during road transport and is not recommended. Step number 5. Check disc leveler blade angles. Blades should be at maximum angle, but not touching. The latest mountings have limited adjustment. When less than maximum blade angle is used, the blades walk over clods and residue, so the leveling is not satisfactory. The excessive bouncing movement creates excessive wear on the pivot areas. Step 6. Check spacing of leveler arms. Each arm should be centered between the shanks. Field settings. Step number 1. In the field, remove transport collars and install matched depth collars on both lift cylinders. Shank depths in charts are relative guides. Depth will vary with soil type and moisture content. Step number 2. While moving slowly, 1 to 2 miles per hour, lower the unit to operating depth. While still moving slowly, adjust the disc depth to the proper 3 to 4 inch depth. Disc depth can affect shank depth. Then stop to check shank depth and front to rear levelness. Steps 3 and 4. At normal speeds, when the power is cut, the disc blades lift the front and the shanks pull down the rear. Stopping from normal speeds, 5.5 miles per hour equals 8 feet per second, will give inaccurate blade depth readings. Step number 3. Check shank depth behind the rear outside shank. If not satisfactory, change both depth collars and repeat steps 2 and 3. Step 4. Check levelness. To check levelness, remove the loose soil behind the disc blades. The cutting depth of the front and rear disc blades must be the same. It is better to compare the outer disc blades, but do not compare the smaller outside front blade with the full-size rear blade. If the front disc and rear disc blade depth are not the same, the field will be left ridged and excessive blade damage could occur on the deeper blades. To correct levelness, raise or lower the clevis height as needed. Then repeat steps 2, 3, and 4. Step number 5. With the disc section set to proper depth, with the gauge indicator in the green, install disc cylinder depth collars to limit disc depth. This will protect the disc from being operated too deep which can cause choking and damage to the blades and hubs. Step number 6. At normal operating speeds, set the disc leveler depth to leave a small berm. Blade depth controls the amount of soil that is moved. A small berm left over the shank path allows for settling. When the desired berm is achieved, set the cylinder stops to limit leveler depth. To determine approximately how much the berm will settle, step down to firm the soil behind the disc leveler blades and behind the shanks. When firmed, the soil should be level under both feet. The depth of the disc leveler may need to be readjusted as residue conditions or soil types change. Each time the shank depth or front to rear levelness is changed, the disc leveler must be readjusted. Step number 6. Note, pulling a crumbler behind the Ecolo-Tiger will firm and level the berms and prepare the surface for the next operation. This works well when you expect to plant, apply chemicals, or root zone band fertilizer before the berms will have time to settle. Step 7. All berms should be uniform across the swath. If they're not uniform, the spacing of the mounting arms should be adjusted slightly right or left to correct the problem. Once these are set, they should not need readjustment. As an explanation, at higher speeds or when cover boards are used, the soil is thrown farther and the ridges are left closer to the center of the Ecolo-Tiger. Therefore, the dual blade mounting arms may need to be adjusted 1/2 to 1 inch closer to the center so the two blades split the middle of the shank ridge. Adjusting the blade angle will not correct this problem. The last part of this video shows assessment of the disc hubs, indicating what surface is needed to prevent failures. Step A. Be safe. Insert transport collars, including disc cylinder transport collars, before working under the machine. Step B. Clean the hubs and blades. If you use a pressure washer, do not spray at hub seal area, as this could contaminate the grease. Step C. Clean space between the seal guard and hub. A screwdriver works well, so the hub will turn without rubbing on dirt. Step D. Turn the blades to feel resistance torque and smoothness of bearings. The blades should not spin. Bearings should turn smoothly. Step E. If the blade spins but the hub does not wiggle and the bearings sound and feel smooth, the spindle nut needs to be retorqued to specifications. Use the zerk to fill the hub with grease before replacing the cap. Step F. If the hub wiggles, the seal has been ruined and must be replaced. Listen to the bearing for roughness that could indicate bad bearings. Also check for bent spindles before removing the blade. When disc bearings are run loose, the end of the spindle can bend downward between the bearings. Then the blade angle will appear different. Check for a bent spindle by comparing the blade spacing at the top versus the bottom to an adjacent blade. Step G. Remove the blade, then remove the hub and inspect the grease for contamination. Clean all reusable parts, spindles and hub, and inspect bearing and cups. Do not reuse damaged parts. Reassemble according to specifications. Always replace used seals when the hub is removed.